So let's continue like this. I know it's a bit awkward, but then we are undergoing a change, so you have to bear with me. In our last episode, we saw the panoramic view. That is a bird's eye view about what AI is all about, how it will affect our future, and how it might even change the way we live. That is, change the entire society itself. In this, we'll delve a little deeper and have a data-centric view. A piece of warning here, things might get a bit hotter, but I'll try to make it as simple and interesting as possible. So without much ado, let's begin and embark on our journey to a new frontier.
So first, the introduction. We study tools and techniques of AI. The big picture. Top 4 techniques. First is, how does a machine learn? That is, how does a computer learn to understand a process? And then finally, give us the process. Second is natural language processing. That is how we human beings understand everyday languages. That is English or Bengali or Marathi or Hindi. And how to make the computer understand in the same way. Not just syntax of language, but the context. For example, NLP can show such things that Jane Austen would use the word dangerous in a positive sense. Third is slightly controversial, automation and robotics. In fact, IEEE doesn't even consider automation and robotics to be part of AI, but I have kept it because, as I said, it's a controversial part. And lastly, machine vision. That is whether a computer can recognize a person or not. A person or an object, even colors, and distinguish one person to another person. One of the major application of this field is face recognition. First is machine learning. We have a completely separate section devoted to this. But here, just a short introduction, a really short one. First type is supervised learning. This is a type of learning where features and targets both are specified. The features in a disease detection may include such elements like whether the person is sneezing or not, whether the person is having temperature or not, whether the person is having cough and cold or not. And then the target, whether the person needs medicine or he or she does not need medicine. For example, common cold and cough without any temperature typically doesn't require medicine. Now, instead of doctors detecting it, the machine can be fed such informations and the machine will tell us whether the person should be treated or does not need any medicine. Next type of learning is unsupervised learning, where target is unspecified. Then what exactly is this? Well, this is about grouping customers by, let's say, type of food they buy, or type of clothes they wear, or their age group, or their educational qualification, and then trying to sell something. For example, Amazon Suggest is there as an example. Next is reinforcement learning. Here, the machine does not learn from data, but learns from experience. That is, it learns from the environment via rewards and punishment. For example, this is how a child learns. A child is given a chocolate if she has done a good job, and she is punished if she has not done a good job or done something bad. So this is reinforcement learning. Example, self-driven car, and something like handling a large portfolio in an investment market. Large and diversified portfolio. Last one is transfer learning, still in research area. This is about transferring, rather cross-utilizing our knowledge. Some simple examples would be like a human being understands. If the human being knows how to ride a bicycle, then he or she can be taught how to ride a motorbike. Know how to play classic piano, you can be taught how to play jazz piano. So doing the same thing for machine, that is called transfer learning. So here we are with our first question. Saw 4 types of learning. And we specified who needs what. Okay, so let's start with the NLP techniques, that is natural language processing techniques. We'll see 6 of them. First one, as the name suggests, it is about identifying names of people, names of streets, name of city. There is basically words that are not present in the English dictionary, may start with a capital letter. They can be recognized in this manner. But then this can become really problematic, you can say, or rather tough, when you consider international languages and not just English. For example, a very simple thing in Hindi may mean completely abusive in Marathi and the other way around. Next is sentiment analysis. The most widely used techniques in NLP. The simplest output of sentiment analysis is a 3-point scale, positive, negative, or neutral. So as you can understand from our previous slide, there is a clear target. That is either the sentiment is positive or it is negative or it is neutral. As the name suggests, there are techniques in NLP that help summarizes large chunks of text using two major techniques called extraction and abstraction. Very useful for research scholars and scientists, especially in the, I'll say, the arts faculty, because of the huge amount of papers and books that are published. Aspect mining. This identifies the different aspects in the text. One of the easiest methods of aspect mining is using parts of speech tagging and can convey the complete intent when used in conjunction with sentiment analysis. Next is topic modeling. Check the definition. As you might have realized, this is unsupervised learning. And this is a prime advantage of topic modeling is that it is unsupervised. Model training and a level training datasets are not required. And lastly, I'm sure many of you have used this, Google Translate. The difficult and I would rather say complicated part of this is about the language generation. Remember, this is not just language understanding. This is also about language generation to the translated language. Remember, in sentiment analysis, it is about finding good, bad, and average. As I've already stated, this is slightly controversial. This is the IEEE definition for robots and automation. Take a few seconds. And now the definition for artificial intelligence. As you see, they are completely different things. But to make matters worse, many vendors are now branding about terms like intelligent automation or intelligent process automation. I mean, just add the word intelligent. For the uninitiated, all these jargons can be very confusing and perhaps daunting. For simplicity, you can think the robotic and automation as a software robot that mimics human actions, whereas AI is concerned with the simulation of human intelligence by machines. Next, machine vision. Once again, there is a complete session dedicated to this, but here, just the introduction with some, well, unintended jargons. Remember our first lecture on neuron, where it all started, the Macular-Pitts model? It was designed by Frank Rosenblatt, the classical neural network, which is a combination of many neurons, one after another. He was an American psychologist. It involves the adaptation of the model into fundamental binary data inputs. Next, convolutional neural network. This is an advanced and high potential type of classical artificial neural network model. It is built for tackling higher complexity pre-processing and data compilation. That is the visual cortex. The RNNs were first designed to help predict sequences. For example, the long short-term memory algorithm is known for its multiple functionalities. Such networks work entirely on data sequence of the variable input length. Self-organizing maps. In this type of deep learning techniques, the output dimension is fixed as a two-dimensional model, as each synapse connects to its input and output nodes. Remember the synapse from our very first lecture? This model is unique because of the reason that whereas all others are unidirectional, here there is no predefined direction and therefore has its nodes connected in a circular arrangement. But because of this uniqueness, this technique is used to produce model parameters. Different from all other deterministic network models, this is referred to as stochastic, that is probabilistic, you can say. This is one of the most commonly used type of deep learning techniques, but has a bottleneck, which leads to yielding lesser categories of data and leveraging most of the inherent data structure. And finally, a question. The last of this lecture, I promise. Please note, by memory, I do not mean computer memory. Of course, every model will require a computer memory, but the model's own memory.
All right, so that was it. What we did in this session was effectively we took a bird's eye view on the different techniques of AI. Later on, we'll go into the deeper details of all these different techniques. Hope you enjoyed the session. Till we meet in our next session. Bye for now.
So I started the introduction, and then we see the big data technologies. At the onset, a little bit of history. Punch cards. They were the first effort at data storage in a machine language. The holes acted as on-off switches. This was developed to control textile looms in 1725. It was even used by Charles Babbage, the great-grandparent of computing. Well, the big blue boys, IBM, primarily responsible for driving the early evolution of magnetic disk storage. They invented both the floppy disk and the hard disk, and their staff were credited with many of the improvements supporting this particular product. Gave rise to softwares, flat files, and DBMS, database management systems. But this was not enough. Entered the next generation, data silos. And that is where big data starts. They store data for a business or a department of the business that is incompatible with their system, but is deemed important enough to save for later translation. What was important for their business was stored in magnetic disk storage in form of RDBMS and stuff, organized fashion. But what was unimportant was stored as data silos. For many businesses, this was a huge amount of unused information. And this eventually became useful as a source of information for big data. Eventually, data lakes were created. And lastly, of course, the cloud. Internet, especially the high-speed internet, made this as a service. Improvements within the internet, such as continuously lowering the cost of storage capacity, have made it more economical for individuals and businesses to use the cloud for data storage, though not all types of data. And now, the 3 V's of big data. This definition was articulated by this gentleman, sometimes in the early part of this millennia. First, volume. Massive amount of data, including business transaction, smart devices, are continually being collected. In the past, storing it would have been a problem, but cheaper storage on platforms like data lakes and Hadoop, and now the cloud, have erased the burden. Velocity with which the data is coming in, the speed. IoT is one of them, as I said. Plus RFID tags, sensors, and smart meters are driving the need to deal with this torrents of data in almost real time. Lastly, variety. And here, social media data has made this part all the more interesting with the massive variety of data that it produces, like videos, audios, emails, etc. And now, a question based on the previous slide. We saw the 3 V's. So just point the odd man out. So, how it works? First, a strategy. This sets the stage for organizational success amid an abundance of data, as I said, coming in almost real time. When developing a strategy, it is important to consider existing and future departmental goals and initiative. Sources. They flow into IT systems from wearables, smart cars, medical devices, industrial equipment, and more. You can analyze this data as it arrives, deciding which data to keep or not to keep, and which needs further analysis. Number 2 comes from open data sources, like the government's data, maybe the US government, the government of India, or the European Union open data portal. Continue with this. Social media. This data is often referred to as digital exhaust or data exhaust. Extremely important in today's worlds for both the financial sector as well as the telecom sector to figure out social media leaders, because people tend to follow them in certain aspects. Along with reliable access, organizations also need methods for integrating the data, ensuring data quality, providing data governance and storage, and preparing the data for analytics, the ultimate aim, that is creating the model. Another approach is to determine upfront which data is relevant before analyzing it. With high-powered technologies like grid computing, this has become extremely easy. Either way, big data analytics is how organizations gain value and insights from the data. Last one, and if you remember from our previous lesson, one of the most difficult one, because this is a cultural aspect of change, that is creating data-driven decisions. Businesses need to seize the full value of big data and operate in data-driven way. making decisions based on the evidence presented by big data rather than gut instinct. I think it was Edward Deming who had said, "In God we trust, everyone else brings data." But unfortunately, there has been no chief data officer in any organization I know of. I think it's time. So, based on the previous slide, go through the question. Digital or data resource, what is it? Big data technologies. First, the definition. Just take a few seconds. These are such data sets where traditional data processing softwares are not able to deal with. Types of big data technologies. The first one, they can be online transactions, social media, or the data from a particular organization, etc. You can even consider this to be a kind of raw data, which is used to feed the analytical big data technologies. Example can be online ticket booking, which include your rail tickets, flight tickets, online shopping, as well as the digital exhaust that I've been talking about from social media, Facebook, Instagram, etc. Analytical big data is where the actual performance part comes, and the crucial real-time business decisions are made by analyzing the operational big data. Examples, stock marketing, carrying out space missions, medical field where a particular patient health status can be monitored, and many such. Finally, the classification. We will discuss this in detail. Just take a few seconds to check what are the classes. Okay, so let's proceed. Firstly, the storage. Hadoop was designed to store and process data in a distributed data processing environment with commodity hardware and with a simple programming model, thus making it extremely cost efficient. And of course, as you might be knowing, one of the most popular big data technologies in storage. Next comes something like MongoDB. This is a NoSQL. That is, data is not structured. Now here, what you see in an Excel sheet is an extremely well-structured data. But unfortunately, all data cannot be stored in something like an Excel sheet. Data can often be extremely unstructured and unruly. Yes, you heard the word right. So there we require databases like MongoDB, which offer a direct alternative to the rigid schema used in relational databases, where relation is a must. This allows MongoDB to offer flexibility while handling a wide variety of data types at large volumes and across distributed architecture. Lastly, Ranster, a patented technology, a software company that developed a database management system of the same name, designed to manage and analyze big data for large enterprises. Data mining, check the definition. Major technologies. Presto is an open source distributed SQL query engine for running interactive analytic queries against data sources of all sizes, ranging from gigabytes to petabytes. RapidMiner is a centralized solution that features a very powerful and robust GUI, that is graphical user interface, that enables user to create, deliver, and maintain predictive analytics. The last one is a search engine based on a particular library called Lucence library. It provides a distributed, multi-tenant capable, full text search engine with an HTTP web interface, that is, you can use it on a browser. Analytics. Note the difference between mining and analytics. Be careful. So, the major technology is Spark. It provides in-memory computing, capabilities to deliver speed, a generalized execution model to support a wide variety of applications, and many programming languages APIs are made available, including Java, Scala, and Python. R, of course, the language of the gods. The statisticians love this language. It is a free software environment used for statistical computing and graphics. This language is used by statisticians as well as data miners. Splunk is another one which captures, indexes, and correlates real-time data. Now that is how it is different from the others. In a searchable repository from which it can generate graphs, reports, alerts, dashboards, and data visualization. That brings us to the last one, data visualization technology. Notice what data visualization is. They say a picture is worth 1,000 words. So even before you go to sometimes mining or analytics, many people prefer to first draw a diagram, that is plot. There are many different types of plots. We will see them in our next lecture. But right now, just know that you can tell beautiful stories using data visualization. The most popular one being Tableau. This is a powerful and fastest growing data visualization tool used in the business intelligence industry. Data analysis is very fast with this, and visualizations created are in the form of dashboards and worksheets. Plotly is basically a library, but when used with these technologies, R and Python, they can be potent. And R and Python both are general purpose languages which has many plotting tools which gives you very low level controls on your plot, which are often more powerful and potent than any others. And lastly, a question. All right, so just on our previous slide, among the four, which one is used for modeling?
Hello and welcome. We are about to begin with the third part of our videos or lectures, whatever you want to call it. Here we will venture into the model-centric view. We have seen the panoramic view and we have also seen the data-centric view. Now it's time to enter the model-centric view and understand what actually prediction means. So it will be a rather long session and maybe some of you may find it a bit dreary, but you have to bear with me. I'll try to make it as interesting as possible. There will be some mathematics, but I expect at least plus 10 level mathematics from everyone. So we'll see machine learning in this session. We'll see the three types of major learning. That is supervised, unsupervised, and reinforcement learning. What is data? What is feature? What is target? Etc. And we'll see the difference between the two types of quantitative data that we have spoken about, namely continuous and discrete, and how they are used in machine learning prediction. So let's begin.
Okay, so we start with machine learning. Now, to be very frank, this is a huge topic. And I'd love to go on and on talking about this, but our time is limited. So I'll try to make it as crisp and as comprehensive as possible. First, as usual, we start with the history. Prehistory, popularized by sci-fi authors, Jules Verne, perhaps the grandparent of all sci-fi novels. Then, of course, in more recent times, we got our very own Isaac Asimov, Arthur C. Clarke. In fact, I have already mentioned about it, I think, 2001 Space Odyssey, the real artificial intelligence, HAL. Isaac Asimov fixed those three laws of robotics, which you have already seen. Ancient history. Hebbian learning theory came in 1949, but it had several limitations. Binary input, binary output. The most comprehensive model, though, was given by Rosenblatt's perceptron in 1957, which was the second model. But his model was mostly a black box. He first tried to implement the artificial neuron, which again forms the backbone of most modern day deep learning and neural networks. Modern history. Computers became ever more powerful. 1989, first commercialization from this organization. They released the Evolver, the first software package to commercialize use of genetic algorithms on personal computer. The chip revolution had already begun. Computers were becoming more and more powerful, and it was possible to do complex mathematical calculations on even your home PC. Finally, for programmers, good news came. 2002, Torch machine learning library was created. In fact, the latest one in Python called PyTorch is created to commemorate this Torch, the original library. This is first released, and programmers could start delving into this fascinating world of machine learning. So, types of learning by machine. Supervised. We take historical data. Remember, we had spoken about it earlier, that here we have clear demarcation between the features and the target. For example, who will catch a malignant disease if we have historical data of people with certain features catching a malignant disease, then we can teach the computer to find a relationship between those features and whether the person caught the disease or did not catch the disease. So the computer will learn the rule connecting the features with the target, that is, whether the person was infected or not infected. This is where there are no specific targets. Now, here let me tell you that targets and labels, these are words which are often used interchangeably, or sometimes even classes. So here no labels are given to the learning algorithm, just data is dumped, and the machine is expected, or the algorithm is expected to find out if there is any correlation, if there is any grouping possible. For example, people who buy X might also be interested in buying Y. Reinforcement learning, this is how a child learns. No data is given, program interacts with the dynamic environment in which it is supposed to perform certain tasks. The feedback is in terms of rewards and punishment. That is, the program is supposed to increase as much rewards as it can. Transfer learning, as I said, it is still in the research arena. Earlier also I had mentioned, focuses on storing knowledge gained while solving one problem. That is, you gain some knowledge while driving a car and you apply it while driving or trying to drive a truck. So here we are with our first question, just covered in the previous slide. So, supervised learning, what is the difference between traditional computing and machine learning? Take a few seconds to have a look at this picture. Consider, I hope you're done. So consider that I have a program to convert Celsius to Fahrenheit. All of us know that famous formula. Now, in traditional computing, I will give the program to the computer, that is the formula of converting Celsius to Fahrenheit, and I will give input, some Celsius temperature. And the computer, in turn, will give me the output, that is the temperature in Fahrenheit. Whereas in machine learning, I will not be giving the computer the formula. I will be giving the computer inputs, that is some Fahrenheit temperatures, and the outputs, or rather some Celsius temperature and the outputs, that is Fahrenheits. Now it is the computer's responsibility to figure out the relationship between Celsius and the Fahrenheit and give me correctly the formula. No, it will not give you that formula that we know of, certainly not. But it will find on its own an approximation so that next time you give an input in Celsius, it will correctly give you the Fahrenheit. Now here I need to talk of something different also, that is discrete and continuous variable. Remember from our last lecture, discrete is something that cannot take any value it wants. It can take only certain specific values. For example, whether the person falls ill or he or she doesn't fall ill. Yes, no. Or let us say whether to buy a stock or not to buy a stock. Okay, so these are discrete targets. Whereas continuous target is maybe the marks scored by students. Marks can even be decimal because often teachers like to give a half a mark for certain questions. Or let's say the price of house. There the output is not discrete. It is continuous because price of a house can be anything. It can be any number. You cannot say, no, the price of a house must be the 30 lakhs or 40 lakhs. It cannot be anything else. No, you cannot say that. It can be anything, absolutely anything, even going to decimal places. So if you are thinking in the way of stock market as buy or sell, you will consider the machine learning's output to be discrete. But if you consider the stock market or the value of or the price of certain stock, then the output will not be discrete. It will be continuous. Okay. So an example, notice this data. This is about whether a person defaulted in loan or did not default in loan. 1 means did not default, 2 means defaulted. So the features are status of the person's account, whether it is dormant, whether it is active, whether it is it has not been touched in the past 2 months. Duration, for how long the loan was taken. History of the person means the credit history, how well behaved the person is. Purpose of the loan, whether it is a house loan or a car loan or personal loan. And there are many other features. And the target is discrete over here. Either the person was able to pay the loan or defaulted on the loan. Okay. Now over here we also see something interesting. Notice the duration, they are numbers, so they are numerical data. Whereas notice the status, history, and purpose, they are not numbers, so they are categorical data. I hope you remember that we have classified data in 3 types. That is qualitative, quantitative, and categorical. And I had said that actually categorical data cannot be put straightforward in either qualitative or quantitative, because we can do some direct correlation or find something with this categorical data. That is, we really do not need to quantize them directly. So that is discrete target. Whereas example of continuous target, how much loan is pending. Notice the input feature is same, but the target is now no more discrete. It is continuous. It can be anything. It can even be decimal values. So this brings us to 2 fundamental types of supervised learning. One is classification, which is this, that is whether the person is able to pay the loan or not able to pay the loan, that is belongs to one class or the other. And this is regression, that is predicting how much loan the person is remaining. So if the target is whether you want to buy a stock or not, what type of data out of these 4? So regarding classification, something interesting. Notice this is a spam classifier. So the machine is supposed to detect whether a particular email is a spam or it is not a spam. Okay. Now we take 2 parameters. One is email length and one is recipient. Notice that the number of recipients, if they're more, it is more likely that it will be a spam. That is shorter email length as well as large recipients, that is some guys over here. This implies it is sure shot to be a spam. Whereas these emails which are long and where the number of recipients is also very less, they are to be sure shot non-spams. But sometimes they can be borderline, like over here. But still, we can draw a straight line. We are fortunate. Not always. As you can notice over here. So in the previous case, the targets were linearly classifiable, whereas over here, the targets are non-linearly classifiable. And this can give rise to many other types of complications. There can be many issues. One is algorithmic issue. Bias variance trade-off, we'll soon see what this is. How complex is the function and how much data is coming in as input. Also, there can be data issue, that is noise in the output values. Remember, we spoke about outliers, anomalous values. So that can be an issue. Then another issue can be heterogeneity and randomness. For example, let's say that a busy traffic 4-point square. Typical waiting time over there is 3 to 4 minutes in peak time, but it can get reduced to a few seconds in non-peak time. Now, if the data has been collected only in non-peak time, the machine will come to the conclusion, or rather the algorithm will come to the conclusion, that there is not much traffic over there. That is because the data is not heterogeneous enough. Then, of course, there are presence of interactions. That is, one feature may be dependent on another feature. That is, you are feeling tired and you had to spend in office for 16 hours for the past 3 days. So, of course, you will feel tired. So, remember we spoke about circular logic. So, here it can be circular logic. There may be interactions. As I spoke about complexity, notice the first one. This is a very simple model. A straight line is dividing, but there is only one misclassification. So should we go for it or should we go for this? Now, if there were too many over here, let's say 3, 4 blue dots here and 3, 4 red dots here, I will say that the algorithm, the model has too much variance. And if this line was too crooked, I will say that the model has too much bias. Both are not good things. Because a computer learns just like a human being. We first train the computer with certain amount of data, and then we test the computer with some unseen data. It's just like, a CBSE teacher is given 50 problems and is told that she can use problems from that set to test her students. She is not going to give all the 50 problems to the students. She will hide 10 problems from them. So if the student has wrote up the solution of those 40 problems in the training set, the student will correctly answer all 40. But without understanding it, if the student has wrote up, then the student will fail miserably when it comes to the testing data. Hence, high variance is never a good thing, because you never know whether the model actually learned it or not. So, unsupervised learning. As the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training dataset or tested using testing dataset. Instead, we just dump the data on the model, and the model itself is supposed to find the hidden pattern and insights from the given data, which is not visible to the naked eye. Unsupervised learning cannot be directly applied to a regression or classification problem, that is the discrete and the continuous variable that we saw earlier, because there are no targets here. There is input data, all right, but if there are no targets, supervised learning cannot work over here. And this is, of course, much more akin to human learning, more than supervised learning. There are many reasons to use unsupervised learning. It is helpful for finding useful insights, sometimes crude though, from the data. This works on unlabeled and uncategorized data, which makes unsupervised learning more important for AI. In real world, we do not always have input data with the corresponding output. So to solve such cases, we need supervised learning. Two major types of supervised learning. Note here clustering and association. Take a few seconds to read the two definitions. They may look quite similar, but they actually aren't. Just take a few seconds. So clustering analysis finds commonalities, and since it is finding commonalities, it can also find anomalies between the data objects and categorizes them. So as you can understand that this is used for categorizing. That is, before we feed the categorized data to a supervised model, then as per the presence and the absence of those commodities. Whereas association is about finding relationship between variables in the large database. For example, if a person has bought X, the person is most likely to buy Y2. That is how you might have seen in Amazon. Persons who bought this also bought this. An example. Notice there are 6 pictures, 3 of dogs and 3 of cats. That is fed to the model. Now, note here, I'm not labeling them that these are dogs, these are cats. What I'm doing is I'm just dumping the data. Remember, unsupervised learning is about finding commonalities or anomalies. So the algorithm doesn't know cats or dogs. It just tries to find if there are any common features between them and categorize them as one group, that is the cats, and categorize the anomalies as another group. Maybe dogs, may not be dogs, but certainly not cats. So that is the whole idea behind unsupervised learning. After that, you can always label those guys as cats and label these guys as dogs and then feed them to the supervised learning model and follow the process. So as it is clear by now probably that unsupervised learning is typically the first step machine learning. So here is the complete process. There are the raw data, there are the labels which may come from some unsupervised learning. Training dataset and test dataset, why they're required, I have already covered it. Then there are some technical jargons we are using in the learning algorithm, that is model selection, cross-validation, etc. And then we get the final model. Check with the labels. Note the flow of the thin arrow. I check them with the test dataset. I feed the test dataset directly to the final model and check the labels. And then eventually I am ready to process my new data. So that is how the entire combination goes. Some algorithms for supervised learning. These are the algorithms that are typically used. And for unsupervised learning, typically used algorithms are these. Logistic regression is a probabilistic model. Algorithms like random forest and GBM, they are often called ensemble learning because it is a combination of other models. Meanwhile, in unsupervised learning, we have K-means clustering, K-metroid clustering, principal component analysis. Now, principal component analysis is particularly important for noise reduction. That is where you say less is more. Combine maybe 2 or 3 features into one single feature, and they may end up becoming a more powerful feature. Or maybe related features, and you can combine them to one single feature. So here is a question. I just mentioned about it in the previous slide. Which one is correct? So this brings us to reinforcement learning. First, notice the architecture. Take a few seconds. there is the software agent, maybe a self-driven car. So the environment will reward it or maybe punish it. The agent state changes depending on the environment. Where to push the accelerator and where to push the brake. Definition: a machine learning method that is concerned with how software agents should take actions in an environment. Some important terms: agent, it is an assumed entity which performs action in an environment to gain some reward. Environment, a scenario that an agent has to face. Reward, an immediate return or maybe a delayed return given to an agent when he or she performs specific action or task. State, it refers to the current situation returned by the environment. Policy, it is a strategy which applies by the agent to decide the next action based on the current state. And value V, it is expected long-term return with discount as compared to the short-term reward. So notice, that's the difference. How it works? Very simple example. Apologies to cat owners. So the cat doesn't understand English or any other human language. We can't tell her directly with what to do. We follow a different strategy. We create a situation and the cat tries to respond it in many different ways. If the cat's response is the desired way, we will give her the fish. So that makes cat the agent. So it reacts by performing an action transition from one state to another state. For example, she can go from sitting to walking. The reaction of an agent is an action, and the policy is a method of selecting an action given a state in expectation of better outcomes. After the transition, they may get a reward or penalty in return. The reward may be the fish. Several learning algorithms. In a value-based reinforcement learning method, you should try to maximize a value function. In this method, the agent is expecting a long-term return of the current states under a particular policy. Now, what is a policy? In a policy-based method, you try to come up with such a policy that the action performed in every state helps you to gain maximum reward in the future. Now, note this apparent contradiction between value-based and policy-based. The policy-based is at every step, you try to maximize reward. Value-based is overall reward. Two types of policy-based methods are there. One is deterministic and another is probabilistic. In the last one, you need to create a virtual model for each environment. The agent learns to perform in that specific environment. Lastly, the characteristics of reinforcement learning. Basically, no data. So this is not a data-centric learning at all. It is about experience. That is why I had mentioned absolutely at the beginning that, not in the beginning, in one of our previous lectures, that this is how a child learns. No supervisor, sequential decision making. Sometimes feedback may be delayed, and action determines the next data that comes in. Types of reinforcement learning. Positive. It is defined as an event that occurs because of a specific behavior. This type of reinforcement helps you to maximize performance and sustain change for a more extended period. However, too much reinforcement may lead to over-optimization of state, which can affect the result. Remember, so that bias and variance thing in supervised learning. So too much of reinforcement may cause high variance. Negative reinforcement, strengthening of behavior that occurs because of a negative condition, which should ideally have been stopped. It helps you to define the minimum stand of performance. However, the drawback of this method is that it provides enough to meet up the minimum behavior. That is, you know how it is. Well, this is the pass mark. If I can get the pass mark, that's enough for me. That can be problematic. And now lastly, a question, as usual. So, the last question. Take 1 of 4. No. We saw the types of learning and we saw that the final step is always about the predicted level, and whether it matches the actual level or not. There are many measures. I am not going into the technical details, but you need to know that there are many measures of checking accuracy, but what to use which one. So here is a list. Notice we have used some terminology: false negative, false positive, etc. We will see them at the end of deep learning course. That is our next session. But right now, this is, you can say, an umbrella view or a bird's eye view of all the types of measures of how accurate your model is.
So that was it. We saw lots of data. We saw lots of numbers. We saw the theory behind the machine learning. We saw how a machine learns. That is how the model learns, rather, what we call it, from the existing data and make it ready for the future inputs. We also saw the different types of measures of errors and where they are used in particular cases, difference between the continuous target and the discrete targets. There is a difference between regression and classification, and how it is all about, well, prediction. Hope you guys enjoyed the session. So long.